now. We're on section 9.2 in the textbook. It's page 405. Compound sentences. Compound sentences are also known as conjunctions of two statements, and they're formed by connecting them with the word and. That's your key word. Do I have a red pen and a blue pen? I do. I have a red pen and a blue pen. But now, I do not. I have a blue pen and no red pen. So I cannot say that I have a red pen and a blue pen. But I can say that I have a red pen or a blue pen. And I can do that either way. I have a red pen or a blue pen. Now again, I have a red pen and a blue pen. Seems simple in English, but it's not so simple in math, which is what you'll find out. So here we go. We've got x is greater than 5 and x is less than or equal to 12. So on our number line, we go up to 5. Alec, go ahead. Keep telling us. What do we do?
Draw a circle on 5.
Circle on 5. Open circle, right? Because there's no little line under there.
Don't fill it. And then go to 12.
And we point the way. We go the way of this arrow here. We go that way.
Okay, go to 12.
And we go all the way to 12. And then which way is the arrow pointing there? Yes, Omave?
Red and one blue. And then you have this one, it's another pen, it could be red or blue.
This is also known as a handlebar. Why is this a handlebar? Because you can pretend to grab onto it. That's a conjunction. And, handlebar, right? The lines join, otherwise known as intersection of two solution sets. Solution sets, what the heck are those? Well, this is the solution set of the numbers that are bigger than 5. Not 5, but bigger than 5. Give me some answers. What will work in the solution set of x is greater than 5?
10.
10 will work. What else? 7 will work. What else?
14.
5.5.
18.
Good.
100.
118.
1 million.
Yes. All those. What about negative 5? No. Well, what about 5? No. Because there's no little line there. What about the solution set here? Tina, what are the solutions of this statement? X is less than or equal to 12. 1 would work. 3, yeah. Anything less than or equal to 12, would 12 work?
Yes.
It would. So now, when we want to find the solution set that will work for both, in other words, greater than 5 and less than or equal to 12, we have a more limited number of solutions, right? We can't pick, as we did before, we can't pick certain numbers. Because the solution set to x is greater than 5 could be infinity, 100, 200. All those numbers would work for x is greater than 5, but it wouldn't work for this. So this limits it, and it makes it into this little area right here, the handlebar we call it. That's the intersection of these two solution sets. The intersection of those two solution sets is also known as a conjunction, and you recognize it by using the word and. So let's talk about a couple more.
Wait, can't you have a negative infinity? You can have negative 200.
Yeah, well, no, you can't. Not if it's going to be for both of these. You know why? You could have negative 200 if it was just x less than or equal to 12. But you've got to find the solutions for this and this. That means if it doesn't work for both of them, then it doesn't work for this solution set.
7, 8, 9, 10, or 11.
And 12. Well, you don't. Oh, good question. Good comment. Good way of thinking. Which one do you pick for your answer? Well, the point is, in these questions, there isn't one answer. There are a lot of possible answers. You put this range of numbers. Yeah. This. Well, you don't see the thing is you don't have to write that down. You just represent it like this. And this is your answer. There you go. Just like on the graph we did, some 9.6, 9.5, we were shading lines. Well, what does that shading represent? You tell me. What does that shading represent when we shaded a line? A solution set. Yes, Aaron?
The numbers that'll work.
The numbers that will work. The numbers that will make the inequality work. True. Make it true. Good. So let's do another question here.
I don't think this is right.
So let's look at this one here. Graph x is greater than or equal to negative 2 and x is less than 1. Right? So that one is your standard conjunction. It's going to look like this one. It's going to have a handlebar because it has the word and. So we go ahead and graph that. You want to look for the solutions that will work for both of these, okay? So first of all, less than 1. Are we going to have an open circle or closed circle?
Open.
Open circle at 1. And then on greater than or equal to negative 2, open or closed?
Closed.
Closed at negative 2. All right? And the lines are going to join, all right, right there. You're going to join them up and make a handlebar. That's it right there. Good job. That's as simple as it. Those represent the solutions. The solutions are -2, -1, 0, and everything in between, if you're using decimals. Now, what about any questions from that? Anybody got a question? Ben, you got a question? Anybody got a question? Don, you got a question? No? Got a question? Nobody got a question? No? All right. This is B now. Now, this is trickier, right? Because this is actually the way they give you most of them. But it means the same thing. So you've got to learn to read. You know, just when you thought it was easy, they throw this at you. Ain't that the way it always is? All right? So now how would we do that? What does that say? How do we read that?
-3 less than X less than 6.
That's one way to do it, but the best way to do it is not that. Jessica and Deontay? Jessica?
Would it be 6 less than -3?
6 less than negative. No, you wouldn't do it that way. Deontay? Wait, Deontay? Okay, here's another way to read it. If you read it from the, that's good, that's fine. We can write that. -3 is less than X, and -3 is less than X, and X is less than 6. Okay? Look at that. -3 is less than X, and X is less than 6. But how do we read -3 is less than X? Is there another way to read that? Omave?
Yes.
How do we read that?
-3
Is less than X. That's kind of weird though. Can we rewrite that?
X is greater than -3.
X is greater than -3. That's right. X is greater than -3, and X is less than 6. So we've got it now translated. We had to make a couple switcheroos to get it to the point where we got it to be easy again. We had to it's the same thing. It's the same thing. I mean, technically you don't have to. Honestly, I teach it and I do it the following way. Then this is the mantra. This is what I will hammer home. This is what I will say 1,000,000 times. Go from the variable. Always read from the variable. Always read from the variable. And you can't go wrong. Why? Because if you read -3 is less than X, your head's annoying, is less than 6. If you start reading from the numbers, you get all confused. But if you start with the variable, I go X is less than 6. No problem. If I start with a variable, I go X is greater than -3. I always read from the variable. And I never go wrong. I rewrite it too. But I start from the variable. Hey Lee, what do I do? That's right. X is less than 6, and X is greater than -3.
It's kind of deceptive.
It's deceiving. It's deceptive. But so is there's a lot of things are in life. You can deal with that. You just have to pay attention. X is less than 6. There's a trick to remembering. And how do you remember, Omave? Always read from the variable. There you go. Always read from the variable, and you will be fine. Okay? Don't get confused. Right, Kiara? What do we do to get these chronic problems? Always, what? Read from the variable. Good. There you go. And write it down. Don't hesitate to write it down. Rewrite it down if you want to, or if you need to, or even if you don't. Do it anyway. That's the way to do this stuff. Very tricky. Can be very tricky. Glenda has a question. What's the question?
Are they always going to connect going this way?
They are if they're conjunctions like this, okay? If they have an and in the middle of them, yes. Or if they look like this, they will always be handlebars. And that's a very good point. Handlebar is the thing when you hold on to, right? So now, what about this question? Less than 6 and greater than -3. How do we graph that? Go ahead and graph it. Everybody try. Come on. Look at that. Isn't that a sign of perfection right there? Look at this right here. Greater. It's everything greater than -3.